In the last lesson, we created a construct from scratch, including the setup of the repo itself or the project. Now that might suit you, and you might want to customize everything and fit them to some standards, or you might want a bit of a boilerplate just to help you along and help you ease the burden of some of that setup, things like the linting config, how we do the building and publishing and so on and so forth. So in this lesson, we're going to build an S3 construct with a bit more about it. It's going to do some things that we might expect it to if we were building something for the use of our team or company. So let's do npx ProGen, which is a tool for generating projects from a boilerplate, and it gives you kind of a programmatic way to say, I would like my project to have these attributes and these settings, and then it will create a load of files based on that. It's actually very similar to CDK in the way that it works. You define some configuration, you run the tool, and then it goes and makes some other files to do all sorts of things like your CI pipelines and your linting config and a number of other steps. So let's run ProGen, and then we're going to use new and then AWS CDK -construct. And actually, just before I run this, we need to pop into a new folder. So let's make a fancier S3 bucket. Pop into that folder, and then we can run ProGen. You'll note while we wait for this to install that it's using version 1 of Yarn, and in most of this course so far we've been using npm. I think if you're used to Yarn, this project will be very idiomatic for you in the way they've got it set up. If you haven't used Yarn before, it's not that difficult to get going with for simple examples. And with version 1 especially, it works very much like npm. So I think you should find that things are pretty comparable between the two. All right, so we've got our project generated and we've got a ton of files. So let's open up this project in our editor and we can have a little look in detail. We've got a load of GitHub Actions CI/CD workflows. So we've got a job for building and verifying the changes, making sure that if anything in the project changes after you have done a build, that it lets you know about that. There's a packaging step for JavaScript, given that we can compile, package and ship for many languages with CDK. There's a bit of pull request automation for linting, and we have a full release workflow, building up all the different versions and then optionally publishing them to a number of different places using publib. And then finally, there's a daily scheduled task to check for any updates or upgrades and to produce a pull request if it finds some. In the source folder, we haven't really got anything. We've just got an empty class here, and test again is just empty. We've got a linting config, which is quite a bit more involved than the one we did for our example. It's got lots of rules manually defined. We've got some Git settings and a whopper of a git ignore with various project files in. We've got a config file called for a tool called Mergify, which helps you with merge request automation. We've got the regular npm ignore for files we don't want to be published. And here is the meat and potatoes of it. Here's the file that you give your configuration options to, and then will be used to produce all of the rest of the repo. Obviously not your source code of your constructs, but all the settings and the CI workflows and other bits and pieces. So you can change the things in here, run ProGen, and then you can tell from the synth command here, they're borrowing a lot from the CDK world, and it will spit out options set for various bits and pieces. So that might be better for you, having this sort of setup. This might be worse, depending on if you like to go the route of having it all done manually or whether you prefer to use a bit more of a template. It's certainly not a bad place to start, and then you can customize it as you need things. But that's enough about ProGen for now. Let's crack on with actually making the construct. So we're going to pop this in a separate file, just like we did with the fancy S3 bucket. And we're going to call this fancier S3 bucket. I'm actually not going to suffix it with construct this time. We're just going to call it fancier S3 bucket. We are still going to extend construct, however. And then let's make our constructor, and we've got the same three arguments we always have. We have the scope it's being attached to, which is a construct, a logical ID, and then some form of properties. This time, however, we are going to make a custom properties object that's not extending or using the properties of the S3 bucket by default. So they're going to be empty, and the linting here is going to be complaining that I haven't got anything in this interface, but that's fine. We're only going to have it temporarily. I'm going to set up my props as a third argument. Whoops, copy and paste the wrong thing. And then we'll call the parent constructor with a scope and with an ID. And the linting's still unhappy with me. I don't really think we've got prettier configured in here. No, we haven't, do we? Let's do a yarn eslint fix. And there we go, that's the formatting. All right, we've got a fancier S3 bucket construct, but it doesn't make a bucket. So let's fix that. Let's do a new bucket using the L2 construct. We're going to attach it to the current scope. We're going to call it a bucket. And then we can start examining the properties that we can pass in. So let's have a look at our bucket. Let's have a look at bucket props. And then we can see that encryption here would let us have encryption by default set up for files that are uploaded. So I think it was sensible for us to have that on. So let's say that we are going to use S3 managed encryption. Obviously, if you're doing a lot of cross-account stuff, then S3 managed encryption wouldn't be appropriate. You'd have to do KMS with some more advanced configuration. A customer managed KMS key with more advanced configuration. But that'd be fine for our context. And then let's see what else we've got. We've got an encryption key, which we don't have to specify because we're using an S3 managed one. We can enforce SSL. Let's turn that on. We can say that, yes, we would like to use a bucket key, which is derived from the main KMS key. We're not going to set a bucket name. We're going to use the default of having an auto-generated one. Same for removal policy. We use the default of it being retained. We're not using the removal policy, sorry. So we don't need auto-delete objects. That's not relevant for us. And we will have versioning enabled as a bit of a soft delete style behavior for files we upload. And there's a ton of things that we could add to this if we wanted to. I'll tell you what, actually, let's put public access block on. But really, we need to know what's relevant for your context, your team, your organization. These are just a guess at some examples of some sensible defaults. What we're trying to do in making this construct is making it easier for our end users, which might be other people in the team or another team, to produce something that is safe and defined with best practices. You might then be wondering, well, what are we going to do about the rest of the properties going into this bucket? And I'll tell you what, let's actually change this interface here, our iFancier S3 bucket, to a type, and I need to call it fancier bucket props. And then we're going to say that we're going to take a base type, or a type to start from. In this case, it's going to be bucket props. Whoops, I put backup props there. And then we have fields that we're going to exclude from that type, or keys we're going to exclude. So I'm going to exclude encryption, I'm going to exclude enforce SSL, I'm going to exclude bucket key enabled. And we're doing this because we don't want end users to be changing these or passing them in. We're deciding that these are things that that should stay fixed, where there's a real good reason to have a certain value for them. And let me just fix that property type there, and let's do another eslint fix again to change all the single quotes to the speech marks to single quotes. All right, and now we've got a props property or a variable here, and it doesn't have all of the fields on. It's only got the fields that oh, sorry, I didn't mean exclude, I meant omit. Let me swap that over. There we go. So yeah, we've now got the same props, but with a vastly reduced selection of values here. It's only the properties that we haven't specified in this set at the top. It's not all of the bucket props. There we go. Yeah, omit is the TypeScript type I meant to use, not exclude. And then once we've got that reduced props array, reduced props object, we can spread in the props variable here into our bucket. And that means that we can allow the user to configure anything else they like. So maybe a lifecycle policy, maybe the bucket policy itself, or whatever they think is important. You might then be wondering, well, this is an L2 construct. It's got lots of methods and lots of properties. How do our users use those? And if we want to, we can pass them through. So we could make a private field here, and let's say a private read-only bucket with type bucket, and then we're going to assign that in our constructor. And then we can make a pass-through method. So let's say we've got add lifecycle rule. So let's add that in here, which takes a lifecycle rule. Lovely. And then we can call this .bucket.add lifecycle rule with the same rule. So that's one method of exposing a method that's on the inner construct. And that really is if you are trying to avoid users interacting with the construct directly. And that can be good if you're in a really high security environment, shall we say, where you really have to make sure that something is not used in a particular way. But often it can actually be easier just to leave the inner resource as a public property. Then we don't need that pass-through method because people can just call the fancy S3 bucket .bucket and access it directly. And okay, maybe they might be able to override some of these properties or change some things, but they probably have to do it explicitly. And really, we're just trying to give them some sensible defaults. We're trying to help them produce a good outcome. Okay, so there is our more realistic S3 bucket construct. If we wanted to publish this, we could go through exactly the same steps that we did in the last lesson, building it and publishing it. And it would be a little bit more involved because we're sort of nudged towards this release pipeline in GitHub Actions with the ProGen template. But you could still publish it manually if you wanted to test it out. So I have one final thing to discuss on our construct here, and that is versioning. So one thing we have to be careful on when we're doing versioning for CDK constructs is the impact on end users. I'm sure you're used to semantic versioning, which for NPM packages might be where the API changes. Maybe you now require a field you didn't before. Maybe a field's gone, and thus you'd get a compilation error if a user tried to pass it in. But for constructs, it's a little bit more involved, a little bit more complicated, because we have to decide what a breaking change is. And it might be that we decide that a breaking change is anything where there's some kind of disruption to the infrastructure. So for example, if I produce version 1 of this construct and I change this logical name here, maybe I just want to call it rbucket, maybe I want a more generic name like resource. If I change that logical ID there, the resource in the CloudFormation template will be different. It's going to have a different logical ID, and the physical resource is going to have a different name. And that's going to mean that CloudFormation says, oh, well, you've taken one resource away and you've produced this new resource. It doesn't understand that we've renamed the logical resource. And so the S3 bucket would be deleted. But actually, we've got a removal policy having the bucket retained. So the bucket would stay there and just be sort of left dangling outside the configuration. And then a new bucket would be created. And obviously, if there's live traffic interacting with files in this bucket, or there's data that we need to keep in there, that will cause some disruption or an outage for our end users. And so we might say, okay, if you're going to change this logical ID here, actually that needs to be version 2 now. So we have to be a bit careful to put our semantic versioning hat on and say, right, what is a breaking change in our context? If there's any kind of infrastructure disruption, if there's a replacement, or something being refactored in that way, maybe that means it's a major version change. And maybe that means that it's not relevant for you to do and you sort of have to live with the naming you chose originally. Depends on your context.